So I'm going to list out the variables. So we've got y initial. Let me do this. There we go. We got the initial height. We got the final height. We've got the initial velocity, the final velocity, the acceleration, and the time. So take 30 seconds. I want you to think about what just happened right here. I did this, right? And we know that I caught it after it fell 15 centimeters, so 0.15. There's a 1 in there. There we go, meters. So we know that's how far it fell. All right, so we need 4 values. I want you to think about those and decide which ones you think you know. Take 30 seconds, then we'll shout them out. Think of how many can you think of from this situation? All right, let's shout them out. Somebody tell me one value you think you know.
The acceleration is negative 9.8.
Good, and that's
meters per second per second.
Yes, great. Negative 9.8 meters per second, or meters per second squared. Awesome. And that's the big thing we've been talking about the last couple of classes, is that when something's in free fall due to gravity, the acceleration is negative 9.8. Whether the object's going up, gravity's slowing it down because velocity points up, acceleration points down, or whether the object's coming down, gravity's speeding it up at that rate, or if it's at the apex, gravity's acceleration is still negative 9.8 meters per second squared. Good. Somebody tell me another value you think we know.
The initial position is 0.
Initial position is 0. Okay, cool. 0 meters for initial position. Good. Somebody tell me another value you think we know.
Initial velocity is 0 also.
Good. That's a really important one. I hope people recognize that. Because we talked about when you throw something up in the air, when it reaches the apex, it's got 0 velocity. But if I drop something, the moment I let it go, it also has 0. It's kind of like the apex, because when you release something, it's not yet moving. It requires a little time for gravity's acceleration to change its velocity. Its velocity is 0, and then gravity's acceleration changes the velocity to speed it up. All right, we need one more. Who knows one more value?
Final position is 0.15 meters.
Good, kind of. Let's take a look. So one of the things that I always tell people, right, that I've told you is to draw a diagram. And really all we're going to do here is talk about the importance of the diagram, okay? So here is my ruler, okay? Okay. And the other thing that is so important in the diagram is labeling where 0 is, right? And so we're going to say position of 0. So position of 0, we'll say it's right where that ruler starts, okay? And then we know that that ruler is going to ... fall down, right? And let's say that the ruler ends right about here, okay? So if we say that 0 is where the ruler starts, then where does it actually end when I catch it? I'll give you a hint. If this is where the ruler starts, then 0.15 meters or 15 centimeters would be right here. That would be a location of positive 0.15 meters. So where does the ruler actually end, folks? Somebody tell me.
Negative 0.15?
Yes, negative 0.15 meters, okay? Because the ruler ends down below where it started, which is in the negative direction for up and down, for the y direction. Now, so, and then after that, solving this problem is all just like plug and chug, okay? But so we're not actually going to solve for the rest of this problem. But what I want to show you is this. Let's say that theoretically we did plug everything in and we found time, the reaction time to be like 0. I don't know, let's say 3 seconds, okay? Theoretically, that's not the answer, I'm sure, but I'm just gonna say, let's say we found that. Well, here's the thing. Let's say we had done this. Let me copy this over. Let's say we had drawn our diagram a touch differently. Follow my thoughts here. Okay, let's say, let's say that we had, so anyway, I can get that. Oh, wow, great. Let's say that we had decided that we wanted to put the origin, not there, but down here, okay? So where the ruler ended, and that's fine. You can do that. You can put the 0 position anywhere you want, but let's say that we put it where it ended. And then we went and we listed out our variables, okay? Grab these guys, okay? Copy and paste them over here. Then here's how our variables would look now. Well, now, where does the ruler start? It does start up here at positive 0.15. So the initial position of the ruler is positive 0.15 meters. The final position of the ruler, now it ends at a position of 0, so the final position is 0 meters. The initial velocity is still 0 meters per second. You're still releasing it from rest. It's not moving yet. And the acceleration is still negative 9.8 meters per second squared because gravity is still making it fall. And the acceleration due to gravity, whether you are going up or coming down, is negative 9.8. Okay, and guess what? If I'd used all these values, if I'd done this, right, because those are different from these, and I plug them into my equations, my answer for time would be 0.3 seconds. It would be the same either way. And this moral of the story that I want to kind of like drive home here is 2 things. Number one, you always got to draw your picture. Drawing your picture and putting 0, 0 in the picture will really help you figure out what your initial position, your final position are, okay? If you don't do that, then maybe like you would have accidentally put a positive here when it should have been a negative. And then maybe as you're doing your calculations, all of a sudden you're like, to get this answer, you're doing like, like, I don't know, you're taking like the square root of like negative, like negative 9, 0.9 or something, you're square rooting that. And you're like, wait, I can't square root a negative number. Okay, so if you are careful with your numbers and you're careful with your pluses and you're careful with your minuses, then you'll never have anything weird happen. You'll never be square rooting a negative number, and you'll always get the correct answer, regardless of where you put 0, okay? And so that's kind of like the second moral of the story. Your negative signs will always work out in your math calculations if you set them up correctly to start with. So if you're doing your math calculations and you're like, oh no, this negative sign is weird, I shouldn't be square rooting a negative sign or something like that, then you know that you need to look back at your numbers. You need to think, should this be positive or negative? Because you must have listed one of your values wrong. Okay, like I said, I'm not actually going to take the time to solve this. I just wanted to show you, because the real hard part, I think, is setting it up. After this is just plugging